A slurry was analyzed for batch settling in a laboratory. The results are partially tabulated and the graph will be shown later. It was observed that the critical height occurs after 40 minutes. For the first question, complete all the black cells in the table. It was observed critical height occurs after 40 minutes. Therefore, this part is considered as a free settling zone. So in free settling zone, this equation should be used, and substituting the data from the formula, you will get a terminal velocity of 1.125 centimeter per minute. And since in free settling zone, terminal velocity is constant, we can equate this equation to terminal velocity. Then substituting, we can get this time as a 22.22 minutes. And for this part, it is a hindered settling zone, this formula should be used. So this part is the hindered settling zone. So this formula should be used in hindered settling zone. So for you to be able to compute the data, you should first get the constant. For you to be able to get the constant, since this part is the height is given and also the time, this data that this is the data that I use for me to get the constant, which is 0.0262. And for the remaining unknown, I use this formula. The height and the time is dependent on the given data. For example, for me to compute this height, I use the time, which is 60. So I substituted the time here, and then I got 19.8 centimeters. So, and for the time, I use 16.4. I substituted here the height, and then I get the time, which is 59.97. And for the remaining unknown, I use that formula. So for the second question, if this data is used for a batch cylindrical tank which is 3 meters tall and 1 meter in diameter, how many days will it take to settle particles to a height of 60 centimeters from base? So the required in this this problem time, which is in days. So this is the given, and from the given I got 20, so 60 is 20% of 300, and for me to get the time, I use ratio and proportion. And to get the 20% of 75 centimeter from this, I multiply it by 0.2, and I got 50 centimeters. So from this table, the 15 centimeter is here, and so I got 50 centimeter, and the time, which is 75, and the 60, and then I got the time, which is 300 minutes, or in days, 0.2083 days.
Using the completed table in A, complete the plot. So this is the completed table that was solved earlier. Use this chart to find the minimum diameter of a continuous thickener that can concentrate the safe slurry from 200 mg per liter to 1,500 mg per liter using a feed flow rate of 10,000 liters per day. use the Talmadge and Fitch method. So these were the data given from the problem.
To complete the graph, you must first plot the remaining points after the critical point. So first is the 19.8 and 60. So 19.8 by 60 somewhere like here, and then 16.4 and 69.97. Ito. Walang yung, so 15 and 75. 13.77 and 80. And 10.90 and 100. 6.4 and 150.
And from this, the critical height is 5 until infinity. So ito pang graph. Then you're going to connect the dots. And this is the final graph. The first step is to project the straight line downward. Then compute the underflow height, or the ZU. And ZU is equals to the given data. We now substitute the given. And we will get 10 cm. Then we will going to plot. We're going to draw a straight line. This, you will bisect this angle. You will draw an angle bisector. This is the angle bisector. Using the mirror, this area and this area should be equal. Then draw a tangent line, extending the ZU. From the intersection of tangent line and the ZU, you can get the theta U, which is around 93 minutes. On the graph, we've got the time from the underflow, or the theta U, which is equal to 93 minutes. So using this formula, we can get the area. And this is, and substituting the data, we can get 861.11 centimeters squared. Then, since area is equal to pi over 4 d squared, we can get the required, which is the diameter, which is equals to 33.11 centimeters.